Our first task is to put it in augmented form. So 2, 1, -1, 10, -1, 2, 2, 6, 1, -3, 2, and -15. Okay, so question is, what's our first row up? Well, what's our goal? Our first goal should be to get the 1 in the top corner. And I can very easily see that I can do a row swap to do that. So I want to row swap 1 with 3. All right, so 1, -3, 2, and 2, 1, -1, and 10. And row 2 I didn't touch. Okay. So now what? Well, going to do our next row up here. I want zeros underneath, so I can see that if I add row 1 to row 2, sorry, row 1 to row 2, and swap that out for row 2, that'll put a 0 there. And then as far as row 3 is concerned, there's a 2 sitting at that bottom corner. Well, what can I multiply the 1 by to get it to cancel out with the 2? And that's -2 times row 1 plus row 3, and swap that out for row 3. Okay. Now again, if you have to write this out, this process does take a long time, but the more you do in your head, you'll find the quicker it goes. So if you want to try to do it in your head real quick, that's fine. But I'm going to go ahead and write it out by hand. So I've got 1 plus -1, -3 plus 2, 2 plus 2, and -15 plus 6 is what goes in for that row 2. Okay, so I did not mess with row 1, so I'm just going to copy him over. That gives me 0, -1, 4, and -9. 0, -1, 4, and 9, -9. Okay. All right, then I have -2 times row 1 plus row 3. So I'm just going to set up 4 of these combos since I know I'm going to have to do 4 of them. And let's see how that works. Let's see, so -2 times row 1, so I need the row 1 to show up. So 1, -3, 2, and -15. And then I need to add that to row 3, which is 2, 1, -1, and 10. Okay, and then I just need to simplify that out. So that top one is 0. And then I get -6 plus 1, which is 7. And then I get, what is that? -4 minus 1's -5. And then I get positive 30 plus 10, so that's 40. So I get a 40 there. All right, now what? Now what is my next goal? I'm going to slide this over. I need that very center position to say 1. So if I just multiply row 2 by -1, so negative row 2 in for row 2, that should fix that problem. Okay. All right, so let's see what we got here. We did not mess with row 1. Or we did not do anything to row 3. All right, row 2 is the one that we are going to multiply -1 by. So that gives me 0, 1, -4, and positive 9. Okay, so there's our result. Okay, so now what's our next goal? Our next goal is to get a 0 underneath that 1. Okay, so I need to multiply 1 by something to add it to the 7. So if I take negative 7 times row 2 and add that to row 3, that'll fix that up for me. Let's see, so I'm not messing with row 1 or 2, so I'm just going to bring those over. 0, 1, negative 4, and 9. Okay. And I've got 4 of these little combos. So I'm just going to set up 4 blanks so that I can go back and fill it in. All right, so I want negative 7 times row 2. Okay, so that's 0, 1, negative 4, and 9 is row 2. And I'm adding that to row 3. So 0, 7, negative 5, and 40. Okay, so that gives me 0 for the first one, 0 for the second one, which is good. That's the whole reason why I made that choice. Then I get, negative 28 minus 5, so I get 23. And I get negative 63 plus 40, so that also gives me negative 23. All right, well, that's good. Oh, I see what's happening. Okay, so then come over here. What's my next goal? My next goal is to get that 23 to say 1. So we'd like to say divide by 23, but since we're only allowed to multiply, we're going to multiply by 1 over 23 in for row 3. All right, so the first 2 rows didn't change, so I'm going to keep those the same. Oops, I got so excited. I just copied. I was just copying rows. Okay, so I'm going to go through each number and basically divide by 23. So I should get 0, 0, 1, and negative 1. Okay, now I know part of my answer. Yay! All right, so what does that bottom row tell me? The bottom row tells me that z is equal to negative 1. Okay, so now I need to look at the second row. The second row says y minus 4z equals 9. So y minus 4 times, and what was z? Z was negative 1. Right, so I get y plus 4 equals 9. So what is y? Y is 5. All right, and then we go to our top row. Oops, a little too far there on the scrolling. All right, so our top row says x minus 3y plus 2z equals negative 15. So x minus 3 times something plus 2 times something. All right, so let's fill in our numbers. Y we said was 5, and z we said was negative 1. Okay, so x minus 15 minus 2 equals negative 15. So x minus 17 equals negative 15. Okay, so what is x? So we're going to add the 17 over, and we should get 2. Hopefully get 2 on that. Okay, so our ordered triple is 2, 5, negative 1. So far in dealing with matrices and row ops, we've only really addressed what happens when you're solving a matrix and you end up with a single solution. So now what I want to do is I want to go back to those special cases, go back to the inconsistent system and the dependent system, and take a look at how that looks mathematically when we're generating out our solutions. And really, we're just going to compare the 3 different types in matrix form, just so we can get a sense as to what it looks like. So in this first matrix, notice they're all in row echelon form. Kind of scroll down so you can see that bottom one. So they're all with ones in the diagonals, zeros underneath. And so, but what do you notice that's different about two of them? Take a good look. Okay, I'll give you a hint. Look at that third row. Do you notice anything interesting about that third row? Because that's really what we're gonna focus in on. Okay, so let me go back up. Now in that first one, what do all those numbers mean? Well, that means x plus 2y minus z equals 0. And that second row means y plus 2z equals 3. And that bottom row says z equals 2. Okay, well, how many different solutions would that have? That's actually a previous problem that we've already seen. That one actually has only one solution, and we worked it out to be 4, -1, and 2. And if you're thinking, wow, that's magic, how do we know that? Just scroll back up. If you look at the past two examples, we actually ended up with this matrix, not the last one, but the previous problem. So you have seen this before. Now, what about that second row? What about that second set of matrix? Okay, so that 1, 3, -4, and 8 means x plus 3y minus 4z equals 8. Then that second row means y minus 11z equals 5. And the last row, there's no z. All right, so we just have 0 equals 4. Well, now wait a second. What is that all about? Well, that just means that there's no, does 0 equal 4? No, that's false. Okay, I know it's been a while, but think back to the previous lesson when the variable disappeared and we left with a false statement, right? What do we get? We got that there were no solutions, all right? Okay, so how do we write that mathematically then? Well, we either say that the set of all possible numbers is empty, which is what that means, it's an empty set, or we actually just indicate that there's no solutions. Now, if anyone asks why, we get to say fancy things like, well, it's an inconsistent system and whatever. Now, the third case is where it gets a little interesting. Okay, so this says, make sure we translate these equations here. This says x minus 2y plus z equals 4. And that says y minus 3z equals 7. And then I get 0 equals 0. Okay, so again, notice the variables disappeared and we're left with a true statement. Okay, so this would be a situation where it's a dependent system, where essentially we're looking at a set of lines that are on top of each other. It's a little more complicated in three-dimensional planes, but I think that's an okay statement to think for ourselves. But in this case, there are many good solutions, right? But in a college level setting, that's not enough to simply state that there's many solutions. Because it's not that there's any solution, it's not that there's any, just that there's a lot of them, right? There's an infinite number of them, but I can't just pick 3 random numbers and have them work. So I have to make a mathematical statement about, well, which pattern of numbers would work. Okay, so just bear with me for a moment here as to what I'm doing, and hopefully this will make sense when I get to the end, or not, but just give me a second here to set this up. What I want to do is I want to rewrite x and y in terms of z. So I'm going to go up to this second equation, so the y minus 3z equals 7, and I want to just get y by itself. Okay, so that's y equals 3, so the minus 3z becomes positive, so positive 3z plus 7. Okay, I'm going to write that down for a second. Then I want to come over to the other equation, that x. And again, I want to get x by itself in terms of the other two. So bring the y over. So that's 2y minus z plus 4. Okay. Now what I'm trying to do here is I'm trying to say that it's not that I can have any numbers I want. I'm going to let z be whatever it wants to be. It can be any number at all. But once I've picked a z, then I'm locked in for x and y. So I'm going to define x and y in terms of z. Well, right now I've got a lovely equation in terms of y and z, but remember a second ago, I just found this lovely equation for y in terms of z. Okay, so I get x equals, and that would be 6z plus 14 minus z plus 4. And I can see that there's some like terms there. So 5z plus 18. Okay. So how do I write out this lovely solution? And I kind of wish I had put more space in my box here. So I'm going to use set notation, and I'm going to say that it's x comma y comma z. So I'm going to define the variable, and then I'm going to say such that x equals 5z plus 18, and that's a comma. Y equals 3z plus 7, comma, z is any number. Now, just so we get a sense, I'm going to write that as though I didn't have this limited amount of space to write on. Okay, so x equals 5z plus 18, y equals 3z plus 7, and z is any number. Okay, so whenever you're dealing with a dependent system, that's how your answer is supposed to look. That's not, again, not sufficient to say, well, there's a lot of good, many solutions. We want to be very specific about what type of solutions we're dealing with. And you're not going to like my answer to this, but why? Why am I doing this? Why does it matter? Right? Well, you're in this class to be very technical and to learn how to be technical. This is a technical skill. It's a very nice technical skill, but it requires that we pay attention to a lot of detail and are very patient as we're writing out our final answers.